It's definitely a wet, rainy day out there, so let's take this opportunity to talk about water. Possibly the first thing to note is that water is ridiculously common, one of the most common molecules of the universe. Hydrogen is the most abundant element in the universe, and oxygen is the third most abundant, so lots of water in the universe makes sense. In 2011, the largest reservoir of water so far was found in a cloud around a black hole 12 billion light years away. How much water are we talking? 140 trillion times the amount on Earth. Of course, in space water either vaporizes if it's too hot, or freezes if it's too cold. It's liquid water that is really hard to find, or at least this was the thought before it was found all throughout the solar system. Some moons even have more water than Earth does. Anyway, a few fast facts. The formula for water is H2O. You need an oxygen atom and 2 hydrogen atoms to make a molecule of it. It's the most common substance on Earth, comprising 5% of the mass of the Earth. It's essential to all life. It's one of the 2 things that we think are needed for life to occur: water and an energy source. Now for some physical properties of water. It's odorless, tasteless, and almost colorless. Hang on, I can taste water, you're thinking? No, you can't. Actually, it's the impurities and dissolved gases in water that give it smell and taste. If you were to drink pure water, you're likely to think that it tastes gross, even though it actually has no taste, simply because you were used to water with stuff dissolved in it. Now hang on, back up to that almost colorless part. Most people think water has no color, but actually it's intrinsically a faint blue color. This is hard to see in a glass of water, but if you look into a large body of water, like the oceans from space, the blueness is very apparent. Actually, the way in which water is blue is pretty special too. The color is caused by weak absorption in the red part of the visible spectrum. Here's where it starts to get funky. The absorbed photons promote transitions to high overtone and combination states of the nuclear motions of the molecule. That is, to highly excited vibrations of the molecule. Water is the only substance in the natural world that exhibits a color caused by excited vibrations of the molecule. Everything else owes its color to the way light interacts with the electrons of a substance. Cool, hey? Now, water is of course the only substance on Earth that occurs naturally as a solid, ice, a liquid, water, and a gas, steam. Let's take a look at some other properties. pH. Pure water is neutral with a pH of 7, but water self-ionizes or self-dissociates, so even with pure water you actually have H2O molecules as well as the hydrogen ion and hydroxide ion. Now, I say the hydrogen ion, you would never actually have that because it grabs onto a water molecule and straight away you have the hydronium ion. At any given instant, this self-ionization happens to about 1 in every 10 million water molecules, i.e. 10 to the minus 7, which gives a pH of 7. Remember, pH is a measure of the amount of hydronium ions present. Now, a pH of 7 says that water is neither an acid nor a base, but actually it can act as either. Pure water is neutral because when it self-ionizes, for every hydronium ion there is a hydroxide ion. However, water is amphoteric, which means it can act as an acid or as a base. An acid is a proton donor, and a base is a proton acceptor. Consider the following. In this example, hydrogen chloride acts as a Bronsted acid by donating a proton to the water, and the water acts as a Bronsted base by accepting the proton. The resulting solution is acidic because it contains hydronium ions. In this example, water acts as a Bronsted acid by donating a proton to ammonia, which acts as a Bronsted base by accepting the proton. The resulting solution is basic because it contains hydroxide ions. Conductivity. Pure water is an exceedingly poor conductor of electricity. It will conduct a little bit. It has ions after all, remember? If an ionic salt, for example sodium chloride, is dissolved in water, it dissociates into its ions. Now, electric current is the flow of charges, and because there are positive and negative ions that are free to move throughout the solution, electric current is able to be conducted. The solution is called an electrolyte. freezing point and boiling point. The freezing point of water is 0 degrees Celsius at 101.325 kilopascals. This is atmospheric pressure at sea level. The boiling point of pure water at 101.325 kilopascals is 100 degrees Celsius. As altitude increases, atmospheric pressure decreases and the boiling point becomes less. In Canberra, the boiling point of water is about 98.5 degrees Celsius, and at the top of Mount Everest, it's about 71 degrees Celsius. Density. The density of most liquids increases as temperature decreases. The density of water also increases as the temperature drops to 4 degrees, but then it decreases as the temperature drops further. As the temperature drops below 4 degrees Celsius, water molecules align themselves so that the slightly positive ends of one molecule are near the slightly negative ends of another molecule. This leads to a more structured form as the water freezes into ice, leaving holes, which makes ice less dense than liquid water. Heat capacity. The specific heat capacity of a substance is the heat energy required to raise the temperature of 1 gram of the substance by 1 degree Celsius. Now, water has an exceptionally high heat capacity of 4.184 joules per gram per degree Celsius. This essentially means that water is really good at absorbing heat. Universal solvent. Water will dissolve lots of different substances. It actually has the highest dissolving power of any liquid. Because of this, we call it the universal solvent. Now, obviously it isn't actually a universal solvent. If it were, you would dissolve yourself when you had a glass of water, or when you took a shower. Or given the fact that you are 2/3 water, you would have dissolved yourself already. So it's not actually a universal solvent. We just call it that because it's good at dissolving stuff. And because it's so good at dissolving substances, water obtained from natural sources is never pure. If you want pure water, you need to make it in the lab. Surface tension. A body of water appears to be covered by a membrane on the upper surface. This surface tension is due to the attraction water molecules have for each other. This attraction is called cohesion. Capillary action. Water will travel up a fine tube or through fine channels in the soil. This is due to the attraction between water molecules and the other surface. The attraction is called adhesion. Viscosity. Viscosity is a measure of the resistance of a fluid to flow, and it varies with temperature. Water has a fairly low viscosity, which means that it's fairly runny. So there we have it. A bit about this most funky of substances, water. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.